RAID levels. RAID is also a storage technology. Previously, already we done LVM concept, logical volume manager. In LVM, it writes the data sequentially one by one disk. But in RAID levels, you can tell the system how the system can going to be writes the data. So we have different RAID levels. We are going to see now what are the RAID levels we are having. The Linux supports which RAID levels. RAID. So RAID means redundant array of independent disks or inexpensive disks. RAID is a storage technology that combines multiple disk drive components into a single logical unit, like LVM only. But here data is distributed across the drives in one of several ways called RAID levels, depending upon what level of redundancy and performance is required. So while writing the data can distribute it across the drives. But LVM, it will not distribute the data across the drives. It writes the data sequentially, one by one. So this is other technology we are going to use in real-time scenarios. RAID is compulsory. Questions they will ask in interview. So Linux supports the following RAID levels: RAID0 Striping, RAID1 Mirroring, RAID5 Parity Stripping with Parity. We have number of RAID levels here: 0, 1, 2, 3, 4, 5. But these are the generally used RAID levels: RAID0 Stripping, RAID1 Mirroring, RAID5 Stripping with Parity, and RAID1 plus 0. Generally, they are called as RAID10, but not 10 exactly. 1 plus 0. 1 means mirroring, 0 means striping. So mirroring with striping, very rare conditions they will use this RAID10. It is very costly. So generally in real-time scenarios, 95% we are going to use RAID 5, striping with stripping with parity. So what is RAID 0? So RAID 0 is stripping. So minimum disks are 2 with equal size. So you can attach maximum 32 disks. So it writes the data parallelly on multiple disks. For example, if it writes the data, for example, who am I? There is a words who first disk, am second disk, I first disk, like that. It distributes the data parallelly on multiple disks. So what is the advantage here? Data writing is fast because multiple hard disk headers will work parallelly. So data writing is fast. And also we can expand the storage limit. Expand the storage limit. These are the two advantages in this. Next, what are the disadvantages? If one disk is fail, the RAID volume fail. So if even one disk is fail also, you cannot get the complete data because the data is distributing on multiple disks. If one disk is failed also, you cannot have the complete data. No data redundancy. Redundancy means duplicated data is not there. Separate data. No fault tolerance. So fault tolerance means if one disk is fail, volume will fail. So no fault tolerance. If one disk is fail, you can have the data that is fault tolerance. But here no fault tolerance. Next to RAID1 mirroring. Minimum disks are 2 with equal size. It writes same data on multiple disks. Same data A, B, B, C, C. So duplicate the data on multiple disks. If one disk is fail also, we can access the data from other disks. It has a redundancy. Say redundancy means duplicate data. We have duplicated data. It has a fault tolerance. Fault tolerance means if one disk is fail also, you can access the data from another disk. So what are the disadvantage? Cost effective. The same data you are using multiple disks. Some of the cost effective. Data write operations are slow because so it is duplicating like Xerox copy. If you write the data again, it is going to copy on another disk. It will take some time. Next, this is the RAID level we are going to use in real-time scenarios. RAID 5 stripping with parity. Minimum hard disks are 3 with equal size. Maximum are 32. It writes the data parallelly on multiple disks with a parity information of other two disks. So what is parity? They will ask the question. A parity is a calculated value to reconstruct the data when a disk fails in the volume. For example, AB data writes on first and second disk. So AB parity information writes on third disk. Like CD writes on first and third disk. The CD information writes on second, like that. Every 2 disks data, it writes the parity of other 2 disks. So first disk, second disk, data writes on third disk. First disk, third disk, data writes on second disk. Second disk, third disk, data writes on first disk, like that. Every 2 disks data, it writes like a parity of rest of the disk. So we have a parity formula is there. Total size of disks by number of disks. For example, 100 GB, 100 GB, 100 GB, I have 3 disks. So 300 GB by 3 GB means 100 GB of the space it is used for parity information. So only the data writing capacity is 200 GB only. Remaining 100 GB it will share equally for all the disks to write the parity of other 2 disks. Here if one disk is failed, we can have you can access the data from other disks. If 2 disks fail, the RAID volume will fail. So 90% we are going to use in real-time scenarios RAID 5 only. Now how to set up this RAID 5 in Linux server? We are going to discuss now. Configuration of RAID 5. Minimum hard disks are 3. So here I am going to create 4 partitions now. F disk space /2/sta p. So already 12 partitions are there. I am going to create 13, 14, 15, 16. So n 1785, so 100 MB I am taking plus 100 MB. Again n 1799 plus 100 MB I am taking. Again n 1813 plus 100 MB. So minimum 3 are enough, but fourth one, so for troubleshooting purpose we are going to use 1827 enter plus 100 m. So here, like, see, how do you identify the normal partitions, LVM partitions, RAID partitions? They will ask the question. At the time of LVM, already I showed you how to change the partition system ID. So if you change or not change, you can configure RAID. But interview point of view, you have to know. Now I want to identify LVM partition separately. I want to identify RAID partition separately. Then we have to change the partition system ID of 13, 14, 15, 16 as a Linux RAID. So partition system ID to change command is T, partition number 13. If you don't know the system ID, give the command L. So here you can check Linux RAID, RAID. There is RAID, Linux RAID. CFD, Linux RAID Auto. So what is the system ID? FD. So LVM 8E Linux RAID FD. Enter P. See Linux RAID Auto Detect. Partition number 14. FD. T. Partition number 15. System ID FD. T. Partition number 16. System ID FD. See, now you can identify those are the LVM partitions, these are the RAID partitions. So if you don't change also system ID also, we can set up, we can work properly. There is no problem. But as a Linux administrator, if you log into one server, you can understand what are the traditional partitions, you can understand what are the LVM partitions, you can understand what are the RAID partitions. Now W. Now update the partition table information to kernel path text. So updated 13, 14, 15, 16. Now configure the RAID. So the package is mdadm meta device administration. So mdadm by default the package is installed. If it is not there, you have to install the package. Now configuration of RAID 5. So simple command in Linux, only one command you can manage the RAID levels, mdadm -C means create. meta device name, logical device name is MD0. So how many disks you are using? Minimum 3, -n, number of disks 3, /2/STA 13, /2/STA 14, /2/STA 15, -L. L means level of the RAID 5. So if you want to configure 0, L0. If you want to configure mirroring, L1, L5. Simple. So there is no separate command. Just to L0 means RAID 0, L1 means RAID 1, L5 means RAID 5. So array is started. Now I want to see the RAID status. cat/proc/mdstat. mdstat. So status is active. These are the RAID volumes I created. Now array is started. It is active now. I want to see the details of RAID. mdadm -detail -scan. So this is the array. This is the meta device version. The name of the server where you are configuring server 24. This is the universal unique identification number of your RAID volume. So this information you have to copy into configuration file. Otherwise, when you stop the RAID, it will not start again because unknown configuration. So this information we have to copy into configuration file. So mdadm -detail -scan. If I give enter, it shows the information. So I want to redirect into configuration file. I want to save this information. mdadm.conf. Now you can check cat space /etc/mdadm.conf. So my configuration information located here. Now what we have to do? So 5 complete details you have to see. mdadm -D complete details of RAID volume. md0 enter. Now you can see RAID level 5, RAID 5, array size, used device size, and RAID devices 3, total devices 3, update time when you created RAID, what is the status of your RAID volume, how many active devices, how many working devices, is there any failed devices, is there any spare devices. So it will show like complete information. Now what we have to do, we have to format the RAID volume. So mkfs start ext4/2/md0 formatted. After formatting, mount the device. mkdir vara RAID, whatever it may be. Now mount /2/md0/vara RAID. So df-h, it displays the mounted information. Now see the RAID volume is mounted. So here shows only 2 GB disk size only. 1 GB it is used for writing the parity formula. Now how to permanent the RAID volume? Open the file va/etc/fs tab. Go to last line. Insert a new line. Now /2/md0. So vara RAID mount point. Sorry, file system type ext4. Permissions are defaults 0 0. Save the file. So here what is the concept of RAID? Go to vara RAID directory, write down some data. So here main concept, what is the concept? If one disk is failed, I can access the data from other disks. So what I am going to do, real time maybe depending upon the scenarios, maybe hardware problems, so maybe disks fail. But how do I know output? How do you know output? What I am going to do, I want to make the one disk as a failover disk. We have the commands are there. I want to make one disk as a failover disk. So to make the disk as a failover disk, mdadm /2/md0. So -f. I want to make STA14 as a failover disk. STA14. So faulty. Now check the details now. Use this command. So removed. So disk is failed. Faulty. Here you can see active devices 2, working devices 2, failed device is 1. So this is the command mdadm -D /2/md0. It shows the status of RAID. So one disk is failed, but the data is accessing or not. How do you check? Go to the mount point. See, the data is checking, so everything is fine. I am accessing my data, I am creating files, everything is fine. Now, how to replace the failover disk in the volume? They will ask the question. So already 4 partitions I created, 13, 14, 15, 16. Now I want to replace 14th disk with 16th disk. MDADM to replace the failed disk. /dev/md0 -a /dev/sta 16. So added. Now check the details. Immediately you can check. Then it will rebuild. See, 16 is replaced. So real times it will take more time because we can have the huge data. It will take time to rebuild the data. But here we have less empty files only. Immediately it is rebuilded. Now see, active devices 3, working devices 3, failed device 1. I want to remove the failed device from array. To remove the failed device from array, mdadm /2/md0 -r, which one /2/sta 14. Removed. Now you can check the details. So now see, fault is not there. Active are 3, working are 3. Now, how to add a spare disk? So previously, we manually replaced, but nowadays, real-time scenarios, they will make 1 or 2 disks or reserve disks. When a disk fail, within fraction of seconds, automatically next disk will add. So previously, manually we added. Now, automatically it will add. So how to add the spare disk to array? Same command, mdadm /2/md0 -a spare. Whatever the disk I removed, I am adding as a spare. sta14. Now you can check the details. So it is not faulty, it is a spare. See, failed devices no, spare device 1. If any one of the disk is failed in the volume, automatically it will replace. So we are going to see that output also. So I am going to make it faulty 13. Automatically 14 will replace. So mdadm /2/md0 -f /2/sta 13. So you can see immediately details. Now see rebuilding. The 14 is replaced automatically. So like this, we can configure the failed devices. Sorry, you can configure the spare disks in the array. Automatically, they will replace. So this is the RAID levels concept we have. Now how to stop the RAID level? Now unmount the RAID volume. So you can check whether it is rebuilded or not. So rebuilded. Okay, active. Now how to stop the RAID? Unmount var RAID. So mdadm -s /2/md0 stopped. Now check the status. Stopped. Model. Again I want to activate mdadm -A /2/md0. How to stop and active the RAID? They will ask the question in interview. How to give capital S stopped, capital A active. Now we can check. So like this, we can configure the RAID levels in Linux server environment. This is the simple way we can access the RAID levels. In other operating systems like Solaris AX, adding, removing, we have number of different commands we have. But in Linux, only one command is mdadm. Like RPM, here also only one command, but options are changed. So this is our Linux administration complete course. We have to practice properly from the beginning onwards, from basics onwards. Each and every chapter you have to practice properly. You have to remember all the syntaxes. So if you have any doubts, you have to contact the Durgasoft people. So they will intimate me. I will give the answers. Okay. So take care, practice properly. Daily 1 hour, 2 hours you have to practice. Then you can get the knowledge of 3 plus 4 plus of years of real-time experienced persons. So when we are practicing, number of errors will come. Troubleshooting that errors is nothing but a experience. So, okay, good luck. Thank you.